Moving into our end-to-end project series, this is the first video of that series. We will be making small projects utilizing different technologies and different programming languages. It is assumed that the learner already know constituent technologies. Let's get started. The first project will be creating REST API using TypeScript. I will be using a scaffolder. There are many scaffolders. We will be discussing them in a while. And then after scaffolding the project structure, we will get into installing required modules and then we'll a TypeScript setup. And as a next step, we will write or change code from JavaScript to TypeScript. Although this step is not necessary if you are using a TypeScript scaffolder, but we are using generic express generator. So we will like to do it manually. Then we will move on to configuration changes for TypeScript. And next step, build and test. And then we will configure for Nodemon so that whenever we do some change in our code, we don't need to restart our Express server. So it will make our development much easier. The next step is to containerize using Docker file. And the next step is to push all of our source code into GitHub public repository. And then we will automate our container build and publish process using GitHub Action Workflow and interesting work. There are several folders available for Node.js with slightly different objectives and advantages. Listed ones are few well-known ones and like Human and Express Generator, Nest CLI, Loopback CLI, Feather CLI, TS Clean architecture. So we will be using Express Generator for the time being because it is simple to use and much familiar. If you have Node.js installed, then you can install any of these scaffolders by giving the npm command with install and -g for the global installation and the name of the scaffolder. Once the scaffolder is installed, you can use the scaffolder to actually create the project structure that will help you to organize all different files and contents. Let's try out Express Generator. The first step is to install Express Generator. We are installing it globally. So we are done with that. Now use the Express to generate or scaffold the project. So I do not need any views here. So it's better to put up this no view option here. I would like to use it for the REST API. So here we have generated the folders and we can have a look at them. Now we need to install the dependencies by executing npm install here. If there are any vulnerabilities or breakings, what you can do here is to call the npm audit fix. That will allow you to resolve all those vulnerabilities. So now we are done with generating a project. The next step here is to install TypeScript. We like to convert this project from JavaScript to TypeScript project. Now we are creating the configuration file. project, we have all the code in the JavaScript. And now we like to convert it into TypeScript. For that purpose, what we need to do is to convert all the code manually into TypeScript. As a side note, I like to introduce a free tool from Google that is called Gemini Code Assist. It can always help you to convert the code or understand the code that you don't understand directly. So let me show it quickly. So here we have our code converted to TypeScript, and we can always copy and paste this or move it just by clicking. Now we have converted all our JavaScript code into TS code. The main files in the scaffolder are www.ts file that is converted from JavaScript to TypeScript. So you can clearly observe that we have import statements here and a number of other places. You can see the changes. Like here, we have strong types here. And if we go to the other files like index.js, the similar kind of changes can be observed here. Like we have request as a strong type and a strong type response. And similarly, we have the import statement there in this scaffolder generated code that we converted. And similarly, if we get into users.ts and then finally the app.ts. So we are pretty much done with the code changes here, and let's move into configuration changes. Now we have to do a couple of changes in our package.json and tsconfiguration.json. The first change we need to make is in package.json, and in the script section we have start that allow us to tell that where we can find our JavaScript to start the application. And the second is the build, and it allows us to use the TypeScript compiler before we execute app.js. TypeScript compiler will compile our TS code into JS code and place it in this dist folder. So if we go to the next step, we have to see the TS configuration. This file allows us to have compiler options, and if we can see that it has options for project, language environment, modules, and if we actually scroll down, we can see that there is an image section, and here we have to uncomment output directory and provide the directory in which we want to produce our JS files after TypeScript compilation. Before I run this code, I like to show you one little change here. I have removed view related code from this endpoint and added a simple send response. So let's try to execute this code. So to build it up again, I will run npm run build. Distribution folder, and we can have a look at compiled files in JavaScript. Now let's run it. Now let's test it. It is our first route. And let's test our REST service /user endpoint. So both are working. So for DevOps, we will be configuring Nodemon for easy development and restarting of Express server. And then we will add a Docker file for containerization. As a third step, we will push our source code folder to GitHub. The last step will be automation of containerization using GitHub workflow and pushing resultant containers into Docker's repository and GitHub repository. Nodemon allows developers to automatically restart Node server whenever there is a change in the source code. So there are 4 steps we need to perform. The first step is to install the Nodemon, then to update the Nodemon .json configuration. You might need to create it manually. And the third thing is to change the script section of the package.json to use Nodemon, and then you can run your TypeScript based project using npm run dev. To install Nodemon, npm install fixing the auditing. The second step involves adding a configuration file for the Nodemon with the components like which particular directory we like to watch for changes. Here we say that we like to watch everything in the root of this project. That means in this particular folder, Xnode backup API, and then what kind of extensions we like to watch, TS extensions, and then ignore. In ignore case, what particular subfolder we like to ignore, and we can list the folders that we do not like to observe for any changes. Finally, it is something that will replace our JS execution, and it is telling us that how to execute or start our server and project. And after this change, there is another change that we need to do is in our script area. Here now we have to replace everything with this particular line, dev nodemon, and we are specifying the item we want to execute. npm run dev. It started and working. Now let's make some changes in files. Maybe here. And it is restarting. So it's working. Docker is an open source platform for developing, shipping, and running applications in containers. Containers are lightweight, portable, and ensure consistency across different platforms and environments. By packaging all necessary dependencies and configurations within the container image, it makes it easier for us to ship the image and then to create containers from it and run our application within container. So what we need for that is 3 things. First thing is that we need to install Docker, Docker Desktop, and Docker VS Code extension. I've already installed them for this video, and you can visit the Docker website if you like to install it on your machine. The second thing that we need to do is to create a Docker file in our source code that will contain information about how to create a container, and look at a snapshot in this slide as well. And the third thing we need to do is to do some modifications in our package.json to enable it to start our Node.js application from within the container. The last thing that we need to do is to build our container. We need to call the docker build command along with a couple of parameters that include the image name and the directory that contains the code that we like to containerize. In this case, we will be executing this command from within our project folder, so it is dot. I have done few changes in package.json to make it work within the container. The first thing is build TSC. I have that build TSC available again. because we are no more in dev environment, and then the start that will allow us to start our application from within the container by calling the transpiled GTS code and by calling www.js as a starting point. Okay, let's start Dockerizing our application. The first thing we need to do is to create Docker file. This is a convention that D should be capital. I've already written some configuration here, which I'm going to paste. So I'll be explaining it in a moment. So in the beginning, from Node, in that case, we are using the official Node.js image as a base image. Then we are defining the directory for our container with the work directory /user source/app. And we will be referring it by /. Then we are copying all the package files into the work directory of our image. Then the third step, we are running npm install to in our container, then the Typescript, and I'm installing the TSC watch, which I'm not using at the moment, but we will try to use it in future videos. Then I'm copying all those files in my current directory from where I'm running the docker build command to the current directory, that is app, of my container. Then finally, I'm running the npm run build to transpile the code and create the distribution folder. Then if we get here to the last few lines, then expose 3000, it is exposing the port 3000. And be sure that your own settings within the code, especially in www.ts, also maps to the same port. If we go and look here, then we can see that we have port 3000 here as well. Then the last thing, we are starting our node application. We will be using docker build command to create our image. Docker build -t stands for the tag, and hex node back API is the tag name, and dot is the current directory that will be containerized. Then let's do it. So it's built. The next step is to run it. So for running, we will be using this command, docker run, and -d is to detach, and -p is to map the host machine port to Docker internal port. So we will be mapping port 80 on host machine to Docker image port 3000, and xnode backup API is the tag. Let's run it. So container is now running, and we can test it. Now it is time to test our containerized application. So first route. Now hitting the other endpoint. It's working as well. This is Docker desktop application. It provides us an opportunity to manage all our images and containers. We can pull images from Docker Hub, and we can also see images that we locally built, just like the one we just built, xnode back API. And we can run these images and have containers here. In this listing, we can stop different containers, and we can also test them. Let's log into GitHub and create a repository for our project. I need to execute 6 different commands to get my source code from my local machine to GitHub repository. So let's add this to Git. Initialize Git repository. The second command I'd like to execute is git add docs. So I'll be adding all files to Git repository in this folder. The third thing that I like to do here is to commit those changes. And the fourth thing I like to do here is to link it with our GitHub repository. The next thing I like to rename front branch to main. And then I like to push all of these files to my GitHub repository. If I switch to my browser here, now we can see that all the files are properly uploaded in appropriate repository. I like to introduce two plugins in Visual Studio Code that can be helpful while developing. One is this Docker's plugin that will help you work with containers, stopping them, restarting them, attaching a shell, and getting into it, looking into the files inside the container. And similarly, you can do a lot of other things, attaching a volume, attached volumes, and network configurations. Let's go to another plugin, that is the JIT plugin. If you change any file in the source code, this plugin will help you to check in your code. As soon as you change the file, you will see something appearing here that is telling you there is a change. And in order to check it in, you can add something. It is a test change. I'm committing it from the UI. Push it to my repository. I have created two repositories in my Docker Hub account. One is private and one is public. So after that, I need to access my account settings to create security keys that can help me to access my repositories using an access token. GitHub project settings allow us to create deploy keys that help us accessing GitHub automatically or using GitHub tool. Create a deploy key here. GitHub repository has secrets and variable section that allow us to store secrets like access token, password, and username. I have placed my secrets on the repository secrets of my project settings. Is to create a folder named .github. So I have a GitHub folder here, and in this folder I will create another folder called workflows, and inside that folder named Docker In this folder, I need to create a file docker build push.yml. Let's discuss docker build push.yml. Docker workflow help us to create and push our containers to online container registries like Docker Hub and GitHub repositories. I brought in a template from the GitHub workflows documentation and changed it to serve purpose. Here we can see that it starts with publish Docker name, and then it will be activated whenever we have a new release. And then if you have a look at other things as push to registries, it provides a runner name that Ubuntu latest will be the runner for this YAML file or the workflow, and we have provided some permissions here for read and writing. Then in the next step, we have different actions, and we can see a lot of actions on workflow marketplace. At the moment, we are using some key ones here. One of the primary ones is action checkout, and this is something that will actually copy our code from the repository to the runner. And the next step is to log in into our Docker Hub repository using the secrets we have stored in GitHub secrets. And then after that, we will be using the same action to log into our GitHub registry, and then after that, we are extracting the meta. This action will help us extracting the meta that we will be using to tag our images. And as a next step, we are pushing our images, creating and pushing our images into Docker Hub and GitHub repository GICR, GitHub container registry. So this is pretty much for the workflows, and let's try them out. Now let's try to run our workflow. So we have this file available here, docker build push.yml on github.com, and let's try to create a release. Let me give a new tag, maybe create a new tag. And publish this release. And let me go to actions and see what is happening there. Runner is created and it's trying to execute actions that we created in our workflow file. Building and pushing image to Docker. Runner is the temporary machine that is assigned to us to execute this workflow. We can create custom runners as well. So everything is complete, and green is telling us that it completed successfully. So let's go and check our Docker repository that if it has a new tag. So we have the new tag here available with us under this registry. So let's go and check GitHub and see if it is having a similar container. We can locate our GitHub container repository containers under packages section. And if we go inside, we can find this package node backend template. And if we click it, we can see that there is a container available and that we can pull it using this particular docker pull command. Let's try to pull this image onto our local machine from Docker Hub. We'll be using a command here. So we'll be using command here, docker pull I'm already logged into Docker. So we are pulling it from online registry. And if we go to Docker desktop containers, Docker UI, and we can see that we have this bsadi/green forester latest available with us. And if we go to containers after starting it, it will start a container for us. Now let's test the container that we pulled from Docker Hub.